Hey there, and welcome! Today, we're going to pull back the curtain on a huge, invisible source of waste in your electrical system. Seriously, it's an inefficiency that could be costing you real money, month after month, and you might not even know it's there. So, let's get into it and find this hidden cost. I want you to imagine something for a second. Let's say you're running a big logistics company, right? And you discover that a huge chunk of your truck fleet is driving around completely empty. You're still paying for the fuel, the drivers, the maintenance, but they aren't delivering a single thing. Sounds absolutely crazy, doesn't it? Well, that's pretty much exactly what could be happening inside your factory's electrical system right now. So let's actually try to visualize this electrical waste. It sounds complicated, I know, but there's a really simple analogy that makes it all click. Okay, think about the electricity you're using like a big, frosty mug of cola. The part you actually want, the liquid cola itself, that's your active power. That's the good stuff that actually does the work, running your motors, lighting up your facility. But then you've got all that foam on top. That's reactive power. It does absolutely nothing useful, but it takes up a ton of space in the mug. The whole thing, the liquid and the foam, that's your apparent power. And that's what the utility company sees you're using. And this is where it hits your wallet. That useless foam, that reactive power, doesn't just disappear. It shows up on your electricity bill, usually as a pretty nasty penalty. Let's decode how that actually works. The magic number here is called the power factor. It's really just a simple score. It's the ratio of the useful power, the liquid, to the total power you're drawing, which is the entire mug. So, a perfect power factor of 1 means your mug is all liquid, 0 foam. Awesome. But a low power factor, well, that means you've got a whole lot of wasteful foam, and that's when you start paying for it. And here is the line in the sand, financially speaking. For most utilities, 0.92 is the number to watch. If your power factor is above that, you're so efficient they might actually give you a credit on your bill, a bonus. But if you drop below 0.92, they start tacking on a penalty, which is a percentage that gets added right on top of your bill. And just look at the difference that makes. At a 0.95 power factor, you're getting paid. At 0.92, you're neutral, everything's fine. But let it drop down to something like 0.70, and that penalty gets ugly, fast. For every point you drop below 0.92, the penalty can go up by 0.5%. And if you go below 0.72, it might even double to a full percent for every single point. That waste adds up incredibly quickly. All right, so how do we get rid of all that foam and stop paying these penalties? The solution is called power factor correction, or PFC. And the really cool part is, it does more than just save you money on penalties. It actually frees up hidden capacity in your entire system. So this is what a system with a low power factor looks like. See that? A huge chunk of your electrical capacity, the capacity of your transformer, your cables, your switchgear, is being choked out, just supporting that useless reactive power. It's those empty trucks clogging up the highway. But now, watch what happens after you implement power factor correction. Bam! That wasted capacity shrinks way down. The reactive power is now being handled locally, right where it's needed, so it's not jamming up your main electrical system anymore. You've literally just created more room for useful, productive power, all without upgrading a single piece of major equipment. I love this quote because it just nails it. You're not buying more trucks, you're just making sure the trucks you already own are full of valuable cargo instead of empty boxes. You get more work done with the exact same system. It's a massive win for efficiency. But there's another hidden problem that often goes hand in hand with a poor power factor. And honestly, this one is even more dangerous. We're talking about something called harmonics. You can think of it as electrical pollution that is actively damaging your expensive equipment. You know, all our modern electronics, variable speed drives, LEDs, computers, they're great, but they don't draw power in a nice smooth wave. They tend to take quick gulps of power. This creates a ton of distortion on your electrical network. That distortion, that electrical noise, is what we call harmonics, and it creates excess heat and stress on literally everything connected to it. And the costs of this are huge. Harmonics are literally cooking your equipment from the inside out. They cause motors and transformers to fail years before they're supposed to. They make your cables run hot. They cause circuit breakers to trip for no apparent reason, shutting down production. It even forces you to buy bigger, more expensive equipment just to handle all that extra stress. So you're probably wondering, how much is too much? Well, the number to watch is called total harmonic distortion, or THD. Once that number gets into the 10 to 50% range, you are in the danger zone. That's where all that extra heat starts causing real, physical, and very expensive damage to your infrastructure. Okay, so we have two big problems: wasteful reactive power that costs us penalties, and damaging harmonics that destroy our gear. But the great news is that modern solutions can actually tackle both problems at once, leading to way bigger savings and a much healthier electrical system overall. It's really a double win. On one hand, you get immediate cost avoidance. You stop paying those power factor penalties, and you prevent the catastrophic expense of a motor or transformer failing early. But on the other hand, you get to optimize what you already have. You free up that hidden capacity, and you reduce the energy that's just being wasted as heat in your wires. Now, where you actually install these solutions really matters. Putting one big unit at your main switchboard is the simplest way to make sure the utility company stops charging you penalties. But if you want maximum efficiency, putting smaller units right at the source, like on a big motor, reduces energy loss through your entire network. Correcting a whole group of loads is a nice compromise. It really depends on what you're trying to achieve. So the path forward is actually pretty straightforward. Step 1, you identify the problem. You get a real analysis of your power factor and your harmonic levels. Step 2, you implement the right fix, whether that's capacitor banks for power factor or special filters for harmonics. And step 3, you just sit back and reap the rewards: lower bills, more available capacity, and a longer, happier life for all your critical equipment. So we've just exposed two major sources of hidden waste that were right under our noses the whole time. It really makes you wonder, doesn't it? If this much money and capacity can be saved by optimizing something as basic as electricity, what other invisible inefficiencies are just hiding in plain sight, waiting to be found? Thanks so much for joining me.